How big is the universe? Before we go outward, remember this planet beneath us already feels impossibly huge. The moon looks close, but every planet in our solar system could fit in the gap between Earth and the moon. Now compare Earth to the sun. You could fit more than 1 million Earths inside of it. Yet the sun is tiny compared to the emptiness around it. Our solar system stretches billions of kilometers outward into the dark. Even traveling at light speed, it takes 8 full minutes for sunlight to reach Earth across that void. The nearest star beyond our sun is over 4 light years away. That is roughly 40 trillion kilometers of empty space. Our sun is just one star among roughly 100 to 400 billion stars spiraling in the Milky Way. Even if you could travel at the speed of light, crossing our galaxy would take 100,000 years. Andromeda, our closest neighboring galaxy, sits 2.5 million light years away across the dark intergalactic void. In a tiny patch of sky, no wider than a grain of sand held at arm's length, we see thousands of galaxies. Scientists estimate the observable universe contains hundreds of billions, possibly even trillions, of galaxies like these. On the largest scales, galaxies are not random. They form a vast cosmic web stretching across unimaginable distances. The observable universe stretches about 93 billion light years across from one edge to the other. The universe isn't expanding into anything. Space itself is stretching, carrying galaxies farther apart every second. But this boundary is only what light has had time to reach us from. Beyond it, space may continue forever. Just moments after the Big Bang, the universe expanded faster than light in an event called cosmic inflation. Some stars are so massive that if placed in our solar system, they would swallow Jupiter's entire orbit. Some galaxies are hundreds of times larger than ours, containing trillions of stars in a single structure. Galaxies themselves gather into clusters, bound together by gravity across millions of light years. Our galaxy is part of a supercluster called Laniakea, stretching over 500 million light years across. Most of the universe isn't visible at all. Dark matter forms the invisible scaffolding holding galaxies together. An unknown force called dark energy is causing space itself to expand faster over time. The universe is about 13.8 billion years old, and it has been expanding the entire time. There is a limit to how far we can see. Beyond this cosmic horizon, light has not had enough time to reach us. Some galaxies are moving away from us so fast that even light can never catch up to them. From a single human being to an entire galaxy, reality spans scales so extreme, our minds struggle to comprehend them. Even our entire galaxy is just a small member of a much larger supercluster of galaxies. Some structures in the universe span billions of light years, forming walls of galaxies larger than we once believed possible. In the distant future, expansion may carry most galaxies so far away that the night sky grows almost empty. After all this scale, remember, every human story ever lived unfolded on one small world in a vast cosmic ocean. This faint radiation is the oldest light we can see, a snapshot of the universe just 380,000 years after it began. Beyond this visible edge, the universe may continue infinitely or curve back on itself in ways we still don't understand. The universe could be infinite and flat, or finite, but curved, like the surface of a sphere. Some theories suggest our universe may be just one bubble among many in a vast multiverse. Trillions of years from now, most stars will fade, leaving a colder and darker universe. If expansion continues forever, the universe may approach heat death, maximum entropy, where almost nothing happens at all. Right now, in this moment, we exist during a brief bright chapter of a universe almost incomprehensibly vast.